Welcome to this explainer. Let's just dive right in. If you've ever wondered how the massive digital tools we use every single day, I'm talking the ones handling millions of users, manage to do that without crashing and burning, well, you're in exactly the right place. Today, we're popping the hood. We're going to look at the architecture behind our absolute favorite platforms and break down two of the most powerful, popular, and honestly hotly debated backend technologies out there right now, Go and Node.js.
Now, if you spend literally any time on developer forums or tech social media, you're going to see a lot of fierce debate. People are constantly pitting these two against each other like it's some sort of cage match. But we really have to ask a fundamental question here. Are Go and Node.js actually fighting for the exact same crown, or are they solving entirely different problems for entirely different use cases? To figure that out, we've got to cut through the hype and look straight at the engineering reality.
And hey, speaking of hype, let's address the elephant in the room right away. You have probably stumbled across this exact, extremely loud hot take online: Go is dying, right? Critics love to point to its supposedly slow adoption compared to, say, Rust. They'll complain about it having a smaller ecosystem than what JavaScript offers, its notoriously verbose error handling, and a syntax that some developers just find overly simplistic. For years, the internet has used these exact points to argue that the language is stagnating. But is that actually true?
Well, let's look at the evidence. This myth falls apart almost instantly. Just look at the massive tech giants that rely on it. We're talking Uber, Cloudflare, Dropbox, and literally the very foundations of modern cloud computing, Docker, and Kubernetes. They are all powered by Go in production, operating at an absolutely massive, mind-boggling scale. The irony of calling Go dead is that it's quietly been the vital backbone of modern cloud-native infrastructure this whole time. It might not be flashy, but man, it is everywhere.
Historically, there's actually this incredible coincidence that brilliantly illustrates their differences. Both of these giants launched in the exact same year, 2009, but they had entirely different core philosophies from day one. Go was created at Google to fix their really heavy performance pain points of building large distributed systems in C++ and Java. Node.js, on the other hand, was launched to bring JavaScript's event-driven model to the server. And actually, look at that last point on the timeline. Go didn't even add generics until 2022. The Go team is just deliberately, intentionally slow and careful. They prioritize simplicity and predictability over rapid-fire feature releases.
Section 1. Go. Designed for scale, not for trends. With that history in mind, let's really deep dive into Go. The core difference that makes it so unique is its incredibly low memory overhead. This is basically Go's superpower, concurrency that doesn't hurt. You know, in traditional programming languages, spawning a new OS thread is expensive. We're talking 1 to 8 megabytes of memory overhead each. Go completely replaces those with what they call Go routines, which start at just 2 kilobytes. Because they're managed by Go's own internal scheduler, you can spin up tens of thousands of them in a single process without your server even breaking a sweat.
To make this a bit more concrete, imagine you've got a high-throughput notification service, right? You need to push alerts to 50,000 connected users all at the exact same time. By leveraging Go's concurrent functions, each notification just runs in its own lightweight Go routine. It's almost like effortlessly tossing thousands of paper planes all at once. You aren't blocking the main thread, and you aren't wrestling with those strict, annoying thread pool limits. This is exactly how companies like Cloudflare handle millions of operations flawlessly.
But you know, Go isn't just about Go routines. Its build advantages are absolutely massive. Go compiles directly to native machine code. There's no virtual machine, there's no just-in-time compiler warm-up. That means zero cold start penalties, which is a total game changer if you're running containerized environments. Plus, Go's static typing means you are catching entire categories of bugs at compile time. If you accidentally pass a string where a number was expected, your build simply fails right there on your laptop. It doesn't wait to blow up your production servers at 2 a.m.
And that simplicity extends directly to its tools. Go features this really beautiful, batteries-included standard library. It gives you everything you need right out of the box. I mean, look at this minimal code. Just 10 lines for a production HTTP server. You get cryptography, file I/O, JSON encoding, all without downloading bulky third-party frameworks like Express or managing complex configuration files. It's just pure, fast Go.
Section 2. Node.js, the ecosystem king.
All right, let's shift gears entirely and look at the other side of the ring. I want you to take a second and just look at this number, 2.1 million. That is the visceral, completely unmatched scale of the NPM ecosystem, the package manager for Node.js. It's almost impossible to fully comprehend.
If you want to parse a PDF, validate an email, send a Slack message, generate a QR code, somebody has already written a package for it. This massive, sprawling developer pool is a huge reason why Node.js took off so incredibly fast.
But as we all know, NPM is a bit of a double-edged sword. On one side, the extreme convenience is just unbeatable for rapid prototyping. You literally have a pre-built library for everything. But on the flip side, that convenience usually comes with some pretty complex dependency management. I mean, the infamous node_modules folder, with its incredibly deep dependency trees, is a running joke in the developer community for a very good reason. Plus, supply chain attacks targeting these packages are a real documented threat that requires some serious discipline to manage.
Where Node.js truly shines, though, is in I/O-bound workloads. Think real-time communication. Its event-driven, non-blocking I/O model elegantly handles routing, external databases, and messaging, all by operating on a single threaded event loop. It gracefully juggles thousands of connections coming and going. Basically, when your application's biggest bottleneck is just waiting for database queries, waiting for external APIs, Node.js handles it beautifully. This is exactly how tools like Slack built their original highly responsive messaging infrastructure.
And honestly, we can't overlook this massive advantage, the full-stack productivity win. When your backend is Node.js and your frontend is React or Vue, your entire team speaks the exact same language, JavaScript or TypeScript. This means you can share validation logic and TypeScript interfaces directly between the front and backend. Suddenly, those annoying API contract bugs, they just vanish. Code reviews become easier, and junior engineers can be onboarded way faster because the mental model remains totally unified across the entire stack. It's huge.
Section 3. Head-to-head breakdown.
Now that we understand their individual strengths, let's bring both tools to the center of the ring for a completely impartial side-by-side comparison. Putting them side by side really cements what we've been talking about. On performance, Go produces native binaries with consistent low latency, while Node uses the fast but JT-dependent V8 engine. For concurrency, Go gives you those cheap, lightweight Go routines. Node.js uses a single-threaded, non-blocking event loop. And for the ecosystem, Go leans on its curated standard library, whereas Node relies on that massive NPM ecosystem. So Go clearly wins on raw CPU and memory performance for sure. But Node.js, it absolutely dominates on rapid I/O-bound prototyping and full-stack integration.
Section 4. Making the right choice. So the crucial point is, how do you actually choose? Let's move from the technical theory into the practical application. Here are the specific criteria where Go is the undisputed champion. You should definitely pick Go if you're building infrastructure-level tools or CLI applications where fast startup times really matter. Pick it if you expect extremely high concurrency. We're talking thousands of simultaneous network connections. Go is also your best bet if you need mathematically predictable latency rather than just high average throughput, and if you have strict memory footprint limits, simply because Go binaries run so incredibly lean.
In contrast, Node.js is the perfect fit under a totally different set of conditions. Pick Node if your team is already highly proficient in JavaScript or TypeScript. It's really the obvious choice if your application is heavily I/O bound, meaning it does a ton of database querying, file streaming, or API calling. Choose Node when you need a lightning-fast time to market and you want to leverage all those pre-built integrations. Or if your core features revolve around real-time capabilities like WebSockets and collaborative tools, Node is absolutely the way to go.
But here is the ultimate pragmatic twist to this entire debate. It's the secret that top-tier engineering teams already know. Most of them actually use both. In modern microservice architectures, it's incredibly common to use Go for the heavy-lifting core services that require intense performance, while simultaneously using Node.js for rapid feature iteration and front-end facing APIs. They aren't mutually exclusive at all. Honestly, they complement each other beautifully.
So, as we wrap up this explainer, I want to leave you with this final provocative thought. It is time to drop the internet language tribalism. There is no single winner here. Both are mature, extremely battle-tested tools. The only question that truly matters for your next project is, what does your system really need? Analyze your team, analyze your bottlenecks, and choose the tool that fits the actual reality of your architecture. Thanks so much for joining me today, and keep building great things.